Let's solve the problems based on the competitive examination. The question is, if A is the length of the side of a cube, the distance between the body-centered atom and one corner atom in the cube will be, the given options are A 2 by root 3A, B 4 by root 3A, C root 3 by 4A, and D as root 3 by 2A. In BCC, two atoms are present. One atom lies at the center of cube while other lies at the corners of the cube. Hence, the distance between the body centered and one corner atom is half of the body diagonal, that is root 3 by 2 into A. And hence, the given option is option D. The second question is, copper crystallizes in a face-centered cubic lattice with a unit length of 361 picometer. What is the radius of copper atom in picometer? The given options are A 157, B 181, C 108, and D as 128. Let's write down the given data. The unit cell which is present here is face-centered cubic lattice, which is FCC, and a unit length which is given as A, the value is 361 picometer, and hence for FCC the radius formula is given as R is equal to A divided by 2 root 2. Therefore, R is equal to 361 into 10 to the power minus 12 meter, which is 1 picometer, divided by 2 root 2. Upon solving, we get the value of R as 127.6 picometer, which is approximated as 128 picometer. And hence, the right option is option D. The next question is, the radius of Na plus and Cl minus ions are 95 picometer and 181 picometer respectively. The edge length of NaCl unit cell is, the given option are option A 276 picometer, option B 138 picometer, option C 552 picometer, and option D as 415 picometer. The solution is, we know that NaCl has FCC structure. In FCC lattice, we have R plus R minus is equal to A by 2. Therefore, the edge length A can be given as 2R plus 2R minus. By substituting the value 2 into 95 plus 2 into 181, we get the value as 180 plus 362. Upon adding, we get the value as 552 picometer. And hence, the right option is option C. For tetrahedral coordination, the radius ratio R plus divided by R minus should be, the given options are A 0.4142, 0.732, option B greater than 0.732, option C 0.1562, 0.225, and option D as 0.2252 to 0.414. The solution for the above question is, we all know that for tetrahedral coordination, the radius ratio, that is R plus divided by R minus, should be between 0.2252 to 0.414. And therefore, the right option is the option D. The next question is, if Z is the number of atoms in the unit cell that represents close packing sequence ABC, ABC, then the number of tetrahedral voids in the unit cell is equal to, the given options are option A, Z, option B, 2Z, option C, Z by 2 and option D as Z by 4. ABC arrangement of layer is found in CCP system, that is cubic close packing system. In this, atoms are at the corner as well as at the center of the unit cell. Therefore, number of atoms per unit cell is eight into 1 by 8 plus 1, which is equal to 2. Therefore, number of tetrahedral voids in a unit cell is two into number of atoms per unit cell, which is equal to Z. Therefore, tetrahedral void is 2Z, and the right option is the option B. The next question is, AB crystallizes in a BCC lattice with edge length A equal to 387 picometer. The distance between two oppositely charged ions in the lattice is, the given options are option A 300 picometer, option B 335 picometer, option C 250 picometer, and option D as 200 picometer. The solution is, for BCC, R plus R minus can be given as root 3 by 2 into A. From the question, we know that A is equal to 387 picometer. By substituting the value of A in the main equation, we get the value of R plus R minus as root 3 into 387 divided by 2, which is equal to 335.15 picometer. And hence, the right option is option B. The next question is, the metal crystallizes with a FCC. The edge of the unit cell is 408 picometer. The diameter of the metal atom is, the given options are option A 288 picometer, option B 408 picometer, option C 144 picometer, and option D as 204 picometer. The solution is, for FCC lattice, we know that 4R is equal to root 2 into A and R is equal to root 2 by 4 into A. And we can also further simplify this equation as A divided by 2 root 2. And from the question, we know that edge length A is equal to 408 picometer. By substituting this value, we get R as 408 divided by 2 root 2, which is equal to 144 picometer. In order to calculate the diameter, we have the relation D is equal to 2 into R, which is equal to 2 into 144 picometer, which is equal to 288 picometer. And the right option is the option A. The question is, the number of carbon atoms per unit cell of the diamond unit cell is, the given options are option A 4, option B 8, option C 6, and option D as 1. The solution is, carbon in diamond crystallizes as FCC, that is face-centered cubic crystal lattice, and possesses 4 more carbon atoms that are found to be present in alternate tetrahedral voids. Thus, the number of carbon atoms can be calculated by ZF is equal to ZFN FCC plus ZFN alternative tetrahedral voids. Further, let's solve the FCC unit lattice, where 1 by 8 into 8 plus half into 6 refers to FCC unit cell, plus 1 into 4 refers to tetrahedral voids. By solving this, we get the value of ZF as 8. Hence, the number of carbon atoms per unit cell of diamond unit cell is 8, and the right option is option B. The question is, which of the following unit cell having maximum number of atoms? The given options are A. BCC, B. HCP, C. FCC, and D. cubic. BCC means body-centered cubic lattice, HCP is hexagonal close packing, FCC is face-centered cubic lattice, and cubic is the simple cubic structure. Let's calculate for FCC. In FCC, there are 4 atoms per unit cell, which is maximum, and that can be calculated by the formula of number of atoms per unit cell. Eight into 1 by 8 plus 6 into half, which is equal to 1 plus 3, which is equal to 4. And hence, the right option is option C. The question states in this way. Silver crystallizes as FCC. If radius of silver is 144 picometer, then its density will be, the given options are A. 10 gram per centimeter cube, B. 5 gram per centimeter cube, C. 15 gram per centimeter cube, and D. 6.5 gram centimeter cube. The solution is, firstly, let us convert the radius unit picometer into centimeter by using the conversion factor 1 picometer is equal to 10 to the power minus 10 centimeter. Then, for FCC, radius R is equal to root 2 by 4 into A, where root 2 by 4 can be simplified as 0.3535 into A. Therefore, R is equal to 0.3535 A. Now, let us consider the radius of silver. 144 into 10 to the power minus 10 centimeter. Substituting in the above equation, we get the edge length as 144 into 10 to the power minus 10 divided by 0.3535. And the value of A is 407.35 into 10 to the power minus 10 centimeter. And we all know that for FCC, number of atoms per unit cell is given as 4. By substituting this value in the density equation, D is equal to Z into M divided by A cube into Na, where Z is 4, M is the molecular mass of silver, A cube is the edge length, and Na as the Avogadro number. Let's substitute these values in the main equation. 4 into 108 divided by, and the value of A as 407.35 into 10 to the power minus 10 the whole cube into the Avogadro number 6.023 into 10 to the power 23. By simplifying the above numerator and denominator, we get the value of D as 10.6, which is approximated to 10 gram per centimeter cube, and hence the right option is option A. The question is, volume occupied by single cesium chloride ion pair in a crystal is 7.014 into 10 to the power minus 23 centimeter cube. The smallest cesium-cesium internuclear distance is equal to the length of the side of the cube corresponding to volume of one cesium chloride ion pair. The smallest cesium to cesium internuclear distance is nearly. The given options are A. 4.4 angstrom, B. 4.3 angstrom, C. 4 angstrom, and D. 4.5 angstrom. The solution is, the volume occupied by cesium chloride crystal is given by 7.014 into 10 to the power minus 23 centimeter cube. The volume is nothing but A cube, which is equal to 7.014 into 10 to the power minus 23 centimeter cube. By taking the cube root of this, we get the value of A as 4.125 into 10 to the power minus 8 cm cube, which is further simplified to 4.12 angstrom, which can be approximated as 4 angstrom, and hence the given option is option C. The next question is, if NaCl is doped with 10 to the power minus 4 mole percent of strontium chloride, that is SrCl2, the concentration of cation vacancies will be, and the given constant is Na is equal to 6.023 into 10 to the power 23 per mole, which is a Avogadro number. The given options are option A 6.02 into 10 to the power 15 per mole, option B 6.02 into 10 to the power 16 per mole, option C 6.02 into 10 to the power 17 per mole, and option D as 6.02 into 10 to the power 14 per mole. The solution is due to the addition of strontium chloride, each strontium ion replaces 2 Na plus ion. Thus, it creates a cation vacancy. Doping of NaCl with 10 to the power minus 4 mole percent of strontium chloride means 100 mole of NaCl, that is 10 to the power minus 4 divided by 100, which is equal to 10 to the power minus 6 mole. As each 1 mole of strontium 2 plus ion introduces 1 cation vacancy, therefore total number of cation vacancy is 10 to the power minus 6 into Na. By substituting the value of Na, we get 10 to the power minus 6 into the Avogadro number 6.023 into 10 to the power 23 per mole, and the final value is 6.023 into 10 to the power 17 per mole, and hence the right option is option C. The next question is, with which one of the following elements silicon should be doped so as to give p-type of semiconductor? The given options are A. Germanium, B. Arsenic, C. Selenium, D. Boron. P-type semiconductors are obtained when silicon or germanium are doped with traces of elements of group 13. that is indium, boron and so on. Therefore, the right option is option D.